James-Stein encoding. James-Stein encoding is another variation of target mean encoding. It aims to reduce overfitting by shrinking the category specific target means towards a global mean. Now, what are its advantages? It reduces overfitting. It also improves generalization, but it still has few drawbacks. Particularly, it's defined only for normal distributions. It assumes the data is normally distributed. It also sensitive to shrinkage factors. Now, let's take a look at code sample to understand how it can be implemented. For James-Stein encoding, one of the way could be to use category encoders library and import James-Stein encoder. We'll be using the toy dataset with temperature, color and target. Temperature and color both are categorical variables. We create the data frame first and then initialize James-Stein encoder for these two columns. After that, we do a James-Stein encoder fit transform with the categorical variables, temperature and color column, and you use the target variable. The encoded data frame is returned. And you can see here, these are the encoded values of temperature and color. Next, we can also build a function using NumPy and pandas. We're using the same dataset, same fields. Here, we'll define a James-Stein encoding function which takes data frame as input. We give the column and the target. First we calculate global target mean. Then we compute the mean and count for each category. So here we are using pandas group by. Based on each column, group by target, and then we aggregate on mean and count. Then we compute category variance. Then we compute between category variance of the category means. So we are using NumPy np.var to calculate the variance. Then we also calculate the within category variance within each category. For that, we are using a lambda function with np.var for each element by using the apply method. Then we apply the shrinkage based on James-Stein estimator formula. We use a new variable called lambda, which is within variance divided by within variance plus between variance. Then we use the shrunk mean and calculate the James-Stein mean. In this case, we are using 1 minus category stats using this same newly derived fields lambda value, and then we use the category means and category stats along with the global mean. You can refer to the formula. We return the values after mapping the corresponding James-Stein mean based on the category stats. So for both temperature and color, we are using this newly built function and performing the encoding. And these are the encoded values after running this. That's all for this video. Thanks for watching. Don't forget to like, share, and subscribe for more exciting content on machine learning and AI.